Okay, so we're starting off with functions. Functions always means, for one x, or for each y, there's only one x. No input goes to multiple outputs, that kind of thing. So here's our wording for it. A relation in which each element of the domain is mapped with exactly one element of the range. Nothing in the input can go to multiple outputs. So here we see that 8 only goes to 5, -3 only goes to -2, -4 only goes to 7, 9 only goes to -2. It's okay that -3 and 9 both go to -2. It's just -3 can't both go to -2 and to 7. So yes, this is a function. Each input maps to only one output. Here's where we get the problem. 3 goes to both -2 and 7. So no, at least one input maps to multiple outputs. Here, 5 only goes to 1, 0 goes to 9, 2 goes to 9. Even though this -4 is out by itself, nothing over here goes to more than one place. Here, 0 goes to both -3 and 5. So that is not a function. Okay. Now we need to talk about one-to-one and onto. You can see over here, this is one-to-one, this is not one-to-one. What's the difference? Here's where this is still a function, but now it's not one-to-one because R and B both go to 3. Over here, everything goes to one unique thing. Nothing over here maps back to two different things in the input. So a function where every value in the domain maps to a unique value in the range. R goes to 3, well, nothing else goes to 3. Here, R goes to 3, but B also goes to 3, so it's not one-to-one. That is also called an injection or injective function. Not going to have to worry about that too much, but just want to throw those out there. Onto, you can see the picture here. Basically, it looks like the problem over here, it's not onto because nothing goes to 8 and 1. Over here, everything in the domain, everything in the range gets used. So onto means a function where every value in the range comes from at least one value in the domain. It's called surjection as well, surjective. Okay, let's try it out. Pause it here and see if you can answer these questions about the domain, the range, the function, one-to-one, and onto. When you're done, unpause it, come back and check your answers. Okay, so the domain is all the x values, -6, -5, -3, -1, 6. The range is all the y values, -1, -9, -7, 7, and -9's already been named. We don't need to name it again, but it is part of the range, but we don't need to name it twice. Is it a function? Is there any x that goes to multiple y's? No, -6 does not repeat, -5 doesn't repeat, -3 doesn't repeat, -1 doesn't repeat, 6 doesn't repeat. Each input maps to only one output. Is it one-to-one? Well, here's the problem. -9 comes from -5 and -9 comes from 6, so no. If you remember this, so the x's don't repeat. Here, the y's, to be one-to-one, don't repeat. This one fails that. This example fails. So here we would do a vertical line test, which I'm sure you've done before. You put a vertical line on it and see if it crosses more than once. Well, here we're going to do a horizontal line test. Onto, well, we're only given these things. We'd have to have something in the range that has no mapping, and when we're given ordered pairs, that's not going to happen. So each output is mapped to at least one input. So no problems there. All right. Determine if the following are functions. So we can do the vertical line test and see we're never going to cross it twice. So yes, it passes the vertical line test. Here, no, obviously it doesn't pass a vertical line test. Here at none of the dots, do we have other dots above or below them? So that one does pass the vertical line test. Here we can see right here, it would fail a vertical line test. If we were talking about it, this would be one-to-one because it would also pass a horizontal line test. You wouldn't even check this one because one-to-one has to be a function to begin with. Here, this would not be one-to-one because it's going to fail the vertical line test twice. Here, we have one place where it doesn't pass a vertical line test, so it would also not be one-to-one. Are they functions or not? And if they are, check if they're one-to-one. Pause it here, work these out, and come back and check your answers. Okay, so this one is a function. It passes a vertical line test. This is where people get hung up. This is getting lower and lower the farther it goes out. It's going to pass a horizontal line test. I think we've come across these where the vertical line test, it kind of looks like it wouldn't, but if you zoom in close enough, it would. You just have to kind of know that is going to pass a horizontal line test. Second one obviously is not a function. It's not going to pass that should have been a horizontal line. I apologize. So that's not a function. We don't even check if they're one-to-one if it's not a function. This one is a function. Despite having a gap in the middle, it's still a function because it's going to pass a vertical line test. It never touches a graph more than once. Never touches a line more than once. But it would fail a horizontal line test. So it's not one-to-one. Here, same thing. It's going to pass a vertical line test, but it's going to fail the horizontal line test. Okay, let's run quickly through parent functions. We use these all year. It's just a good idea to get used to seeing the forms of these. First one here is a good old-fashioned linear function, just y equals x. And of course, you get the y equals mx plus b. It moves it around. This is an absolute value function. If you think about it, it's taking all of these negative y values from the negative x's and turning them positive. It's taking this and flipping it up that way. That's what this graph does. This is a good old quadratic, the x squared, ax squared plus bx plus c. This is another power higher. This is a cubic function of x cubed. Then we have, this is a square root function. We don't have anything over here because we can't take the square root of a negative number. But we can take the cube root of a negative number. And this is our good old-fashioned exponential. A will be a number. A will be like 2 or 3 to the x, 4 to the x, something like that. The a will not change. It's a constant. It's called the base. The x is the thing that will change. Okay, there it is. There's our first lesson. And there's the practice for it. Good luck.